This video is an engineering site inspection report for a two-story brick masonry building, which is part of Civil 745 paper on seismic assessment of existing buildings. The site inspection was done on July 2023. Our subject building is located at 25 Victoria Road, Devonport, Auckland, and is one of the several unreinforced masonry commercial buildings west of Victoria Road. The building is located on a relatively flat terrain, and therefore we can confirm that there are no geological hazards in the vicinity that may cause rockfall or landslides. There are also no evidence of liquefaction or lateral spreading in the area. Based on the information we acquired from GNS, the location geology is classified as engineered fill comprised of landfill containing recompacted clay to gravel sized materials. Therefore, for this site, we will be adopting a soil class D. Our subject building is a typical two-story rectangular unreinforced brick masonry structure composed of commercial shops on the ground level and accommodation on the upper level. We can also note that the building is divided unsymmetrically. The front facade is plastered, whereas the side walls and rear walls are not. The right side of our building is bounded by a single-story building, which prevents us from further assessing the condition of the bottom portion of our sidewall. The parapet is made up of 3 different levels, with the rear edge showing some minor damage where some bricks has already fallen off. We can also see a couple of wall anchors, which we suppose are used for the roof, which we will look further into on the later part of this video. The position of the wall anchor suggests that our building has an inclined roof as shown in this sketch. The left side of our building is bounded by a 2-story building which completely covers the wall except the portion of the parapet. Given this information on the adjacent buildings, we can confirm that there are no likelihood of falling debris from neighboring buildings, although there is a potential for pounding. Looking closely at the building separation on the front facade, we can see that there are no visible gaps that can be distinguished on either side. The same can be observed on the building separation at the back of our building. Further inspection of the rear portion of our building, only the upper level of the wall can also be assessed, since the lower level is covered by a newer single-story building. The roof is not accessible for inspection, but we can assume that the old roof has been replaced and is now made of newer material. We can also note that there are no chimneys projecting from the roof, as well as visible ventilation openings. Further inspection of the rear wall shows that it has been completely repointed. Another thing to note is how the repointing was done, which suggests that the bricks has weathered as well and needed to be repaired by mortar. The wall also shows a significant crack running vertically on the top portion. This part of the building side wall shows that mortar on this side has extremely weathered and has not been repointed. We can also identify that the wall has a common bond pattern, which suggests that the walls are double leaf walls with thickness of 230 millimeters. Given this information, we will assume the mortar as very soft with probable strength parameters as shown in table C8.4. The masonry bricks are considered hard with probable strength parameters given in Table C8.3. One thing to note on the roof and floor diaphragms are the exposed anchors, which are considered to be part of the original construction, although we cannot confirm if these are also provided on the sidewalls, as they are covered by the adjacent buildings. The floor diaphragm are constructed of timber where the floor joist runs along the short direction of the building. The original diaphragm penetration, which was the opening for the staircase, is located on the rear end of the building as shown. The condition of the diaphragm is considered fair, with little or no boiler, no water damage, and other minor damages, as described in Table C8.7. Given the condition of the diaphragm, we can now obtain the parallel and perpendicular to joist shear stiffness